I'm joined today on the Siliconomist by Tim Ansell. Tim's a founding father of the open silicon community. He wears many different hats in the semiconductor ecosystem, but the two we really want to explore today. First, Tim spent 16 years at Google, where he did something the semiconductor industry never thought was possible. He convinced a foundry to open source their entire process design kit. PDK was the first fully open manufactural PDK in history and lit the fuse sort of for the open silicon movement that we're living through right now. Second, most recently, Tim is also the founder of Wafer Space. It's a silicon pooling service built to fill the void where Efabless fell off and shut down earlier last year. And the idea is really simple, but it's really radical. It's 1,000 chips of your own custom design for about $7 for each chip. So excited to hear more about that. Wafer Space is just finishing up its first run. It seems to be wildly successful, and we're going to touch base about that and then talk about what's next. So, Tim, thanks for joining us and welcome to the Siliconomist.
Thanks for having me.
Where are we catching you? I know that Wafer Space is out of Singapore. You're from Australia originally. Where are you right now?
I'm
Somewhere in
in
between?
Adelaide, Australia. That's where
Okay.
I grew up. And it's interesting, growing up in Adelaide, I didn't know anyone in tech. Like my mother's a social worker, my dad's a stay-at-home dad / carpenter type thing.
Yeah.
I basically didn't have any connection at all to tech. Until basically in primary school, towards later years, I got the teachers kind of went, there's something strange going on here. He gets like, really good grades in one area and like absolutely can't get like passing grades in another area. And so they sent me off to the psychologist, and the psychologist basically said, look, you've got dyslexia and a few other things. And unfortunately, you've kind of compensated it for such a long time that, it's probably too late to do the mitigations we normally do. But there's these new things that are coming out called computers, and they have a thing called spell check. If he just does everything on, the computer, nobody will know the difference because it will fix his spelling and all that other type of stuff. And so that's kind of how I got into computers. Was basically I was prescribed computers by a doctor. And so, yeah, and like nobody else I know had a computer, and it was supposed to be a learning tool, but I got super frustrated with it that it couldn't play games, and so I wanted to learn to develop that. But I didn't
Yeah.
know like there was a difference between like a Commodore 64 or a like Apple or IBM, and had nobody to tell me. And so I found it very frustrating because like I would type out this Commodore 64 basic program into my IBM PC and like nothing would happen or work in any way.
Yeah.
And so that was kind of like where I started. But eventually I managed to get access to the internet and connect with people over the internet. And through this kind of new thing called open source, I was able to connect with people who are willing to, put up with this guy, like this young kid on the other side of the world asking all these dumb questions. And that's really the majority of the way I got into the tech scene, was through, collaborating with these people on the internet through open source. And so
Yeah.
open source has been a big part of my, it was a long time dream of mine to work on open source full time.
Mm-hmm.
And at Google, I did manage to do that. I eventually ended up on the Chrome team and worked on Chrome for many years. And so I think open source is somewhat a fundamental part of my career trajectory. And like, I'm kind of old enough that I remember like the world before open source. Like I literally had to pay for my first C++ compiler.
Yeah.
I couldn't afford to buy a real C++ compiler. It was a C++ compiler that became in the back of a learning C++ book that was still, super expensive to buy.
Yeah.
At that time, was a very fragmented language. Like every compiler had a different interpretation of how C++ worked and all these type of things. And, there were big lawsuits going on where I believe Bill Gates got up front of Congress and said, these open source people are communists and are going to destroy the computing industry.
Yep.
And now today, we're in a position where Microsoft owns GitHub, where probably 80% of open source is done.
Yeah. And so you start out like that's fascinating. You start out in the software industry and you are now leading a bit of the hardware industry. How did that transition happen?
So I definitely think of myself as a software engineer. Being a software engineer, I think, has a couple of traits. And a lot of that is overconfidence and not understanding how hard things are and thinking that, you could do anything. That's both, a superpower because it means that you do things other people say are impossible, sometimes because, or frequently because you don't know how hard it's going to be to do it. But then,
Yeah.
once you've started, the sunk cost fallacy sticks in, or, there's this new thing I've learned about called spite driven development. Basically, the idea that something annoys you so much that you're doing the development just to, you know, uh, feel that urge. And
Yeah.
so that's kind of an interesting thing was that Google, we were very worried about the end of Moore's law. Before I was Chrome developer, I was part of site reliability engineering. That's the people who kind of run, Google.com and keep it up and that type of thing. And
Yeah.
we definitely saw that, economically, Moore's law was dead, right? Like, while we're still getting more performance, the cost per transistor is not really going down anymore. And Google only really cares about workloads that are growing exponentially, right? Like if you don't have a hope of making it to 1 billion users, you're not a product
Yeah.
Google cares about.
Yeah.
And
Makes sense.
so we looked at that and with Moore's law, keeping an exponential up with an exponential is not easy, but it feels doable. With this kind of slowing down, we were like, well, the only way we're going to be able to keep up with the workloads we care about was to do more hardware. But if we looked at kind of the number of hardware people needed to do things like the TPU project, which was,
Hmm.
Google's very successful machine learning accelerator, if we kind of projected that across, well, we need a TPU for every single product at Google, like one for maps, one for search, all these type of things, we would need to hire every single hardware engineer on the planet by 2030.
Wow. Okay.
Which is not a
Yeah. Not sustainable.
thing you really want to do.
Yep. Yeah.
But Google had been very successful in the software engineering space in making software engineers a lot more productive. As you kind of said, I was at Google for 16 years. When I started at Google, the Google web server, Google has its own web server implementation, used to take about an hour to 30 minutes to an hour to compile. It was
Huh.
like a large giant C++.
Yeah.
Despite the web server getting at least 100x bigger in terms of complexity, by the time I left Google, it would compile in under 5 minutes,
Wow.
despite
It's huge.
getting, 100x more complicated.
Yeah.
The only way Google was able to do that was to develop a lot of custom tools and, put a lot of software engineering effort into it. Uh,
Yeah.
And even open source played a big part of that. Google has hundreds of developers working on things like LLVM because, improvements to that cut across the entirety of Google, right? Like an optimization that makes something 1% faster, is a
Yeah.
really big saving for Google, right? And so I was like, well, why don't we apply the same methodology and way we were working to our hardware development and figure out how to make hardware like our software, right? I had some experience with FPGAs, kind of through some hobby projects I was doing around video recording and creating my own video recording hardware. Um, and I thought that like with things like FPGAs, we could improve that development cycle quite heavily. And definitely I saw things like the open source tools in FPGAs really change the type of engineer that would engage in the tools and what people were able to do.
Yeah.
A kind of example that I think was really interesting is that FPGAs are heavily used in like logic analyzers and scopes and things like that. But what ends up happening is because the Bardo is 30 gig or even more these days, people build reconfigurable systems like for doing the trigger analysis on an oscilloscope as a reconfigurable system on top of an
Hmm.
FPGA, which itself is a reconfigurable system. And so this really cool developer called White Quark developed this tool called the Glasgow, where using open source tools, they were able to basically dynamically and in real time compile new bit streams for the FPGA to like build a trigger circuit, for example, and were able to do that in a way that meant, this FPGA shouldn't have any, like if you look at from a performance and cost point of view, any uh, compatible, like shouldn't be in the same class as like these higher end FPGAs, was able to do it
Hmm.
because it didn't have this extra level of configurability on top of configurability.
Yeah.
And the only reason that worked was because the tools were open and they could pull them apart in ways that you can't do if they're giant black boxes. And so there was a lot of evidence that, when you give people like software engineers access to this, they really will do things that you don't expect. Um,
Yeah.
and one of the big things is that like software engineers frequently work on the tools that they use, right?
Hmm.
Software engineers, because they're software engineers, are able to take the software they're using and improve it, which leads to this kind of nice, feedback loop where, your tools get better the more people who are using them because there are more people who are going like, that thing's wrong and I'm going to fix it
Yeah.
because I have the ability. But also, I'm a software engineer, so I'm overconfident in my ability to fix this thing, right? Like, if I'd known how much work it was to fix that thing, I probably wouldn't
Yeah.
have started, Uh, but like, that's kind of the thing that I think a lot of software engineers have is that kind of
Yeah. That
willingness to
makes a
dive
strong
in and try
case.
to.
I was gonna say it makes a strong case for open sourcing, both the hardware and the software, and allowing people to go as deep as they can, or as close to the metal, I guess, as they can, right? So that came to Google, and you sort of, how did that morph into the MPW project there?
So one of the big things that changed in the software industry over my, career is a lot of the change around things like having continuous integration and continuous releases and all these type of things, right? Like
Yeah.
there's this idea in software engineering, if it's hard, you should do it more often because hard things that you only do infrequently are going to stay hard. And so, and like when I started, releases for software were, big events that happened every, 2 to 3 years, right? And it was always a
Yeah.
big thing to upgrade something because it was a
Yeah.
big change. I think
Yeah.
the modern software thing is like Chrome updates, once every 6 weeks. And that's considered a long time. At Google, pretty much all the servers would update once a week at a minimum.
Yeah.
Some things were on like a 3 times a week schedule. Um, and as well, they were all using like Tipper Tree compiler because the time to fix was a really big issue, right? Like if you have a bug that's causing ads to like, generate less money, for somebody like Google, that is a big effect. And so you don't want to wait, 6 weeks for a fix to land and then get deployed and all these type of things. You want the thing, yesterday. And
Yeah.
so
Yeah.
by having these stuff, running the latest of everything, you detect these problems sooner and you fix them sooner. And where this comes with the MPW program was that basically the idea was to try and increase the iteration speed and also to increase the number of users, because that was another thing that we know from software engineers, that like quality is proportional, not statistically thing, but like the more users something has, the more likely it
Yeah.
is to be more stable, have less bugs, all these type of things. And so how could we increase the number of people doing open source silicon and, actually doing tape outs? And so
Yeah.
that's something that I think a lot of people didn't really understand about the Open MPW program, is that really for Google, the MPW silicon was a carrot or an incentive for more people to use the tool. It wasn't about whether the chips worked or any of these type of things. It was about incentivizing more people to try silicon development.
So
And
these
that
were
was a
so
very
Google was already
different.
using these tools. Sorry if I understand right. Google was already using these tools, and the business logic behind it was if we get more people using it, it'll help accelerate our own internal development, or it'll help, but find more bugs and help make them more robust. Okay.
So Google hadn't started using the tools because they weren't at the standard Google needed them to be,
Okay.
to do the type of development that Google wanted.
Yeah.
But, when Google started with LLVM, it wasn't at the standard Google could use LLVM. And like I worked on
Okay.
Chrome. One of Chrome's big success stories is that it got LLVM to a level to replace the Microsoft C++ compiler on Windows builds. And because for a long time, the Microsoft C++ compiler, while it can compile for 64-bit, internally it's only 32-bit, which means it can't address more than 32-bit worth of symbols in the binary. And Chrome had gone past that number of symbols long ago. And so there was this constant battle of like filtering out these symbols so the compiler could still work. And so Google started a team that was like, we're going to create and get LLVM to a level where we can stop using the Microsoft C++ compiler for Chrome because it's hampering Chrome's development, because we're spending all this time, dealing with, filtering symbols, which is just a thing that we didn't need to do on these other, architectures. But, Windows is a big market. It's not like they could just choose to stop supporting Windows.
The MPW, you internally pushed to get the MPW out, and you took on this project of bringing all the stakeholders together and getting the PDK out there and available for everybody. It's a pretty big undertaking. um,
I think again, it's the hubris of being a software engineer.
sure.
Plus,
Yeah.
coming from the open source world, I can't imagine, like being able to develop software and have parts of that software, like fundamental data for that software locked away under license. That would mean
Yeah.
that you can't do things like CI because you would expose the detail. And so I came in this and I looked, there's actually a long history of open source tooling. Things like Spice originally started as open source.
Yeah.
Magic is still used today. Magic is so old, it's older than I am. And it actually predates the open source movement.
Wow.
Like if you go and look at a license for Magic, it has a
Hmm.
proto BSD license on it because it
Wow.
predates
Jeez.
the standardization of the BSD license. Um,
Yeah.
and so there's this long history of actually open source tooling in silicon, even though these days we mainly think of the big proprietary vendors. There's a big area in open source RTL development, of which I think these days is probably RISC-V is the flagship for that. But
Yeah.
um,
Yeah.
there have been previous open source architectures before that have been used in a lot of different things. So RTL also had a reasonable history, or like libraries and these, of having open sources, places like open cores and that type of thing. PDKs originally were open. Like you said earlier that, I helped release the first open source manufacturable PDK. I technically think you'd have to add the word modern there,
Okay.
because, in the 1980s, a lot of this stuff, was moving so fast, it wasn't necessarily gu- like secretly guarded because you couldn't have that barrier to the people who were using it because nobody knew what they were doing, right? Or how it was going to work. And everybody
Yeah.
was rushing to try and keep up with Moore's law. And so um, barriers basically help slow that down. And so if you could, work with a partner more directly, that could be an acceleration of your development.
Yeah.
And if you look at like academic papers from like the 1980s and like early 90s, you get full images of all the process technologies and cross sections and like full data about this stuff. Uh, which nowadays, you're lucky if you get a picture of the GDS that somebody takes out an academic paper, and even then, it's frequently like the most coarse metal, and it's got like markings all over it, so you can't really understand it.
Yeah.
And like that was super frustrating to me as well. Is that like I can go and look at the big table paper that Google released if I want to understand how, a modern distributed file system might work. And like if you look at machine learning, all the like the transformer paper that, changed and introduced the like current modern age of machine learning is a paper I can
Yeah.
just
All
go
you
and
need.
read. And,
Yeah.
again, as a software engineer, I'm confident that, if I can go and read it, I can go and implement it and these type of things. But like the great thing is that I don't have to because there are other people who are also just as overconfident and have gone and done it for me, right? Like, and so even where Google didn't release Big Tables open source, but like
Yeah.
the paper enabled other people to create open source competitors to Big Table and stuff like this.
Oh, interesting.
And
Yeah.
so that actually turned out to be interesting is that like then Google had a problem is that the rest of the industry standardized on the thing inspired by Big Table that wasn't Big Table. So there was always this impedance mismatch. Um, and so that's kind of some of the reason why TensorFlow was open source is they saw a machine learning happening and they didn't want the
Yeah.
industry to standardize on something that wasn't, you know, they weren't involved in. And
Wasn't
so the
theirs.
best
Yeah.
way to have people use your tools is to open source it. That's kind of my understanding. And, there's lots of different stories about how things happen at Google because, it's a huge place. But that was
Yeah.
kind of my understanding of how TensorFlow ended up being open source, even though it was kind of considered, the crown jewels of Google's machine learning.
Yeah, you make a good space because like you make a good case here because you often hear, okay, if things are open, then people can learn, and that's a good societal good, right? Like that's where you get your next generation of software engineers, your next generation of ideas from the open discussion and the open learning, right? But there is a business case to be said about having things open source in the sense that if you are the technology leader, then people build their standard kind of around you, and that's a counterintuitive moat that's kind of built there, right? By doing that. And that's interesting also that you mentioned that PDKs were previously more or less open sourced and it's a kind of an anomaly of the modern age.
I think it was also PDKs were less of a thing as well, right?
Okay.
Like you got some rules about like it was less like the silicon industry is one of like humanity's absolutely most amazing things I've ever done. It's up there with
Yeah.
like space launch and all these other things like that. And like as the technology got harder and harder, PDKs and stuff started to become more standardized and, started to become a lot more important. And that's when, the industry kind of turned towards these being more proprietary and not shared openly.
Okay.
I think there's kind of a business argument, though, that they're thinking about the PDK development in the wrong way.
Yeah.
Because if you think about it, a foundry makes money from wafers. They don't make money from PDKs. PDKs is a cost of doing business, right? Like they
Okay.
need a PDK to enable people to buy wafers, right?
Yeah.
Um,
Yeah.
and so if I'm in their position, I want as many people as possible out there to have access to my PDK because they are potential customers. Like kind of locking it up means that like you very much reduce the pool of people who can
Yeah,
even
that's a good point.
consider buying
Yeah.
stuff from you, right? It also means that like
You're
the
also creating some
customers,
unnecessary friction for anybody to come in and enter and start using your what you're actually selling, right? Which is the production
yeah,
of your
and
facility. So
again,
yeah.
as a software engineer, or engineers don't like talking to lawyers. I love the lawyers at Google. They were, some of the best lawyers I've worked with at any company and all these type of things. But
Yep.
anytime a lawyer ended up being involved in a project, that
Yep.
project was 6 months minimum type thing, right? Like,
Yeah,
um,
less than fun to talk to.
and
I
so,
gotcha.
one of the secret powers I think of open source people don't realize is that it really standardized licensing of software in many cases. And
Okay.
Google, if you go
Yeah.
and look at Google publishes, or at least did publish, their internal guidelines to their software engineers about, which software you're allowed to use and all these type of things. And they're able to say, like, if this piece of software is released under an Apache 2 license, you're allowed to bring it into Google and use it. If it's released under this license, you're not allowed
Yeah.
to, right?
Yeah.
And you can do that without having to talk to a lawyer, right? Like, and so all of a sudden I can choose to use a piece of software. I don't have to, develop it from scratch and these type of things if it's available under an open source license. Whereas like every piece of proprietary software has its own custom terms that have to be reviewed by a lawyer to make
Yeah.
sure that like in the terms there isn't like, and we'll give you all our AdSense revenue, right? And things like
Yeah.
that, right?
Yeah. Yeah.
And so some of the reason that I think open source has been so successful is just that it meant engineers had to talk to lawyers less and were able to just get on with the work of doing software development and just use stuff that existed without having to ask permission.
Yeah, that standardization kind of just streamlines onboarding and makes it a menu rather than a long discussion with a lawyer. That's really helpful. Yeah. Well, so you've been through this rodeo at least like 3 times now because I think you was it Skywater was with Google and then also Global Foundries and it's HF as well. Now have you've kind of led charges on doing this, but before I get ahead of myself, tell me a little bit. Like right now, you are a founder and operator of Wafer Space. It really rose out of the Efabless ashes. What problem are you solving, and who are you solving it for?
So I think if you look at the history, Skywater was the first foundry that was, willing to make the jump at doing this open source PDK.
Yeah,
And some of the reason was that, Skywater is a much smaller boutique foundry. They have a process technology that isn't, exactly like everybody else's. And, they're based in the US, in Minnesota. They're not one of the people that, you think of when you think foundries. You think of TSMC,
yeah,
Samsung. Maybe if
yep,
you're like, you know, more clued in, you start to see people like Global Foundries and UMC and these other players, which are, billion and billions of dollars of companies.
yeah,
But like Skywater was a small foundry. And so, you know, people wouldn't even consider them because, they didn't even know it was not that they were existent. And so they were like, okay, well, our process technology is from 130 nanometers, which is, 2000, early 2000 era technology. Open sourcing may just be the way to get our name out there, like ignoring anything else. It could just be a marketing thing.
yeah,
And that was somewhat an argument to them was that like, um, you don't know, like customers don't know you exist, right? And this is a way to enable customers to, plus you're
yeah.
a
It'd be a
small
little
foundry,
different.
like,
Yeah,
TSMC probably has hundreds of engineers whose only job it is to make sure that, customers get good PDKs and all these type of things.
yeah,
You have like two people whose it's job to do that, right? Like, um, so by releasing it, you can uh, relieve a lot of that burden of, people asking again and again, how do I set up the BDK, all these type of things, because people will figure out how to do that and, publish instructions, which then when you go to Google, and type in Skywater PDK, you get the
Yeah.
instructions at Google, right? Like if it's all locked
Yeah. Yeah.
behind, a login in the Skywater, you know, corporate access thing, then it's not going to search and be found when you type in like how to set up Skywater PDK. It's not a thing that Google is going to show you because it's behind a closed wall, right? So just from a accessibility and that type of thing was kind of how we were, you know, convincing them that they were open to the idea. And then we committed to a certain amount of spend with them. So there was also money involved.
Yeah.
And so that was kind of what happened with getting Skywater on board.
So for Skywater, I'm sure you had a similar discussion where you told them CI/CD will improve things and openness will bring a bigger community in. But do you think it was, as you said, they had an older process at the time? Did they just have less to lose than somebody who's on a bleeding edge node, or did they
Yep. I
would they?
think open source is a really good for people who um, aren't winning in the current market, right? Like if you look
Okay.
at TSMC absolutely smashing it out of the park if you look at it from a financial point of view and these type of things, right? Like they've figured out how to be the winner in the current market.
Yeah.
But like Skywater had no illusions that could compete with TSMC in TSMC's market, right? Like they didn't have uh, their most modern technology was a 90 nanometer technology. And TSMC was down at the same time already at like 5 nanometer type technologies. So like they weren't going to compete against that. So they needed to do it by something. They need a differentiator, and some of the differentiator is that they're US based. Some of the differentiator is that their process technology is a bit different, and so that has some enabler. And so this open source idea was also a thing that was very much could be another, a differentiator that enables them to, gain more customers and ultimately, again, sell more wafers, right?
Okay.
Because they make
Yeah.
money per wafer sold. And so like they did that and we worked with them to release it and, funded the MPW program to get people to do tape outs and these type of things.
Hmm.
We didn't want to do that work ourselves. So we, found Efabless. Efabless was actually did the introduction to Skywater because we had met them through various other parts. And so we basically had Efabless manage the MPW service for us because we were very much interested in the tools and wanted the MPW service because we wanted people to actually be able to show their silicon work, but like the tooling was where we were really focused.
Okay.
And what we found then, though, was how we got to Global Foundries was Global Foundries started finding that when talking to people that weren't in the industry, the two foundries that maybe a person had heard about was TSMC because, they're the big guys, and Skywater because they were the weird group that was doing this other thing over here, right? Global Foundries is like, we're so much bigger and more important than Skywater. How the hell do these random like software engineers who know nothing about silicon know their name, right? And so
Yeah.
that was kind of like okay, well, like, let's do an experiment with them and open source one of their process technologies following the Skywater approach. Sadly, before we were really able to like wrap that up, if you look at some of the original like presentations I was doing, the big 2023, financial stuff happened, which caused a lot of cutbacks. And sadly, the MPW program was hit by that, which
Okay.
means we were never quite able to get to the level I was originally planning for Global Foundries.
Yeah.
And one frustration I always had with Efabless is that they just, which is like, while I was frustrated with them, I understood their point of view was like they were focused on Skywater because, Skywater already had, 6 MPWs almost 8 MPWs with 40 projects on each MPW already taped out,
Mm-hmm.
and they already had the flow going.
Mm-hmm.
But I really wanted to see people taping out of global foundries because it's a cheaper technology. It's maybe like Skywater has a fairly boutique technology that has a lot of features, which makes it good for
Yeah.
lots of things, but also increases the cost, right?
Yeah.
They're also a smaller company, which means the cost is higher as well, and these type of things. They don't have as much economies of scale as global foundries.
Yeah.
And so like global foundries being cheaper was like, okay, we can make the cost of doing silicon much cheaper if we use global foundries technology, but it will require them to actually, have the time and effort to do that.
Yeah.
And they just never were able to get to that. And so
Okay.
when Efabless went under because of, investor disagreements at the start of 2025, I was kind of like, well, I worked with Efabless. I had helped them, work out their Chip Ignite program from a finance point of view. I'd done all the spreadsheets. I knew how much
Yeah.
things cost. I also knew how much, Global Foundries wanted for various things. I was like, well, I'm pretty sure this business can be profitable and be sustainable. I guess I have to do it myself. And that's kind of where Wafer Space kind of came from, was this whole, well, I think it can be done with a very small amount of people. Like one thing I did was analyze other MPW services. And so there's like
Yeah.
Moses and Europractice and a bunch of other groups like this.
Yeah.
If you look at them, they are very heavy in number of employees because they're very research focused, right? Like
Okay.
they do a lot of custom stuff and all these type of things. But I'm also old enough to remember that PCBs used to be plus for a quote, right? Like, and
Yeah.
the first PCB I ever did, I got like 4 boards for like $1,000, and they were only like 3-layer board, 4-layer boards type thing, right? Like they weren't fancy or anything. And then things like Osh Park and dirty PCBs came along and went, well, like if we pull this stuff together, we can get the cost down. And one of the things we did to make the pooling, or they did to make the pooling work, is they just went, well, we have one offering. You always get ENIC, right? Like there's no
Yeah.
choice. You always get,
Yeah.
X, Y, Z. These are the set of things you do. And they went even further. Like there's this story of Osh Park that I don't know how true it is, but the story is that if you wanted to contact support, the
Mm-hmm.
thing would just give you a refund and say, there are other, companies out there that will be happy to have your business, but you're not a right fit for us, right? Like because it's a very self-service, low
Yeah.
cost thing. They
Yeah.
didn't want to have, hundreds or thousands of people supporting their customers.
Yeah.
And when they
That's a
started,
brave move to make, to
well,
essentially
like the other
reject a
thing is if you
customer,
only
right?
got 5 people or 3 people salaries to pay, right? Like that's
Yep.
a much
Yeah.
easier, to do than if you've got 100 people's salaries to pay, right? And so that's like with Wafer Space, I really think
Yeah.
Wafer Space is probably going to be 5 to 10 people at most for the entire history, even if it becomes, $100 million company.
Yeah.
Because, again, as a software engineer, I'm not afraid to do software and
Gonna try to
automate
automate.
all these
Yeah.
things.
Yeah. Well, so coming back to the like I like the analogy that you use between that and OSH Park. Some of the things that they did was cut down just on options, right? So once you start doing that, it makes things, you getting everybody to you're capturing more economies of scale, and you're also like introducing less problems, I guess. What's the equivalent that Wafer Space does? Like what options are you kind of cutting out, or how are you kind of what are you limiting everybody down to? I guess not limiting, but directing everybody into in
Yep.
terms of technology
We
specs.
basically have one technology.
Okay.
We may support more in the future, but we're not aiming to, have every foundry under the sun or every process technology under the sun.
Okay.
We're focusing on a very small number of technologies as well. I'm focusing on it being profitable and being treated like a low volume manufacturing service. not as a prototyping service. So like a
Okay.
lot of these MPW uh, programs that like foundries run actually run at a loss because they see it as a way to get new customers and have people develop, devices that then they're going to do 100,000 wafers of in the
Yeah.
future, right?
Yeah.
But the number of companies out there that can do 100,000 wafers or something, that's almost a billion chips, right? Like
Right. Yeah.
what
Yeah.
out there a billion chips. But like if you look at the costs and go, well, okay, if we get enough people all buying, part of the reticle, the costs actually become much more reasonable. It's not like anything I'm doing is rocket science. I'm taking a reasonable but not massive size cost.
Yeah.
Because I'm on an older technology as well, I'm not doing a 7 nanometer. And then I'm
Yeah.
dividing it by, say, 40 people. And so that brings the cost down. Uh, as well, I'm not trying to run this as a subsidized thing. I don't have government grants. I'm paying, in fact, more per wafer than probably most of Global Foundries' other customers are because I'm only buying a small number of wafers. But like that, Global Foundries shouldn't be losing money when I'm doing my manufacturing. In fact, they should be making money.
Okay.
And, as I do more runs, I probably will start looking like a more attractive customer because I'm less sensitive to the wafer cost because I'm again dividing it by 40. Whereas if you think
Hmm.
like there are other customers, like say General Motors, who are ordering all these huge amounts of wafers, I bet you they have a team of 5 people whose only job it is to get that price down to just above, Global Foundries margins, right? Where
So just sorry. So if I understand, Tim, like if you look at other MPW programs, you mentioned a few, like thinking of Muse or Music, right? Okay, so they're prototyping. They're loss leaders, though. In some case, like they're gonna be selling it for less than the actual cost, and then TSMC or whoever the foundry is that takes it in, they're allowing that because they're gonna make it up on the backside. They're either this is a prototype, and then once we get it right, we're going to run a large scale run. And you're saying that's not the model we're going to approach. We're going to approach, sorry, the model that we're going to take is not necessarily prototyping, but a small production run. Like you're buying an MOQ of 1,000. Is that right? Yeah, but 1,000, right? And so it's got to be more than just a prototype, but it's less than a massive commercial production run. And that should, and
like
then sorry,
the
and
key
your
thing
price is
here
set so
is
that
that by having like if you look at the number of people who are submitting to the MPW programs, it's a fairly small number, right?
okay, yeah,
And that means that the large cost that is associated with starting a manufacturing run is shared by a small number of people, and so the number is bigger, right? Like
okay.
just based on maths, right? And so the foundries to try and encourage more people help like reduce the cost, governments to try and build their IC industry, give
Yeah.
grants, all these type of things to kind of try and bring that cost down. Whereas my
Okay.
approach is we just need to get more people doing it so that we have a bigger divider uh, and so that everybody is also making money, right? Like because governments, change, and
Yep.
what one government wants to
We've
support
seen it can be
this
fickle.
year may not be want support, and so you need this to be sustainable. It's a different area, right? Like if you want to do silicon research in a way that like customizes a lot of things, Moses and Europractice are much better fits, right? Like I'm really trying to go at that introduction level where like it's cheap enough that people who need 1,000 units or something can afford to do it. And like the kind of breakdown is like 1,000 units, maybe each unit you're selling for $100 or $1,000 by the kind of
Hmm.
3 times BOM cost type rule. If you've got $100 BOM, $100 sales price, means you've got about a $30 BOM. A $7 part on a $30 BOM is a big part of it, but it's not, an unreasonable part of that. And so if that piece of silicon enables you to make your products that maybe you only sell 1,000 of a year, it makes sense to you for that silicon to exist. And that's kind of what low volume really enables, these small products that otherwise can't exist because, they're never going to have a piece of silicon that sells 1 million units, which is what the current industry is all, designed around.
Yeah, geared for. Yeah, that makes sense. So with your first run, right now, do you have a mix of these? Are you seeing startups? Are you seeing small industry or bespoke industry? Are you able to tell us anything about who latched into this first, or who's most interested in this right now?
Uh, so I have a mixture of early customers. You can go and look at our first reticle. Most of the customers will have shared their design. And I think the interesting thing is, like, obviously there's education. The University of Columbia has a project about, teaching people to do transistor design and stuff like that, a project called Mosbius. Then there's a couple of startups, but there's also people who otherwise, you wouldn't think would do silicon. Like, there's a YouTuber, and the
Okay.
YouTuber was like, well, just the ad revenue from, the video I'm going to make about this will cover the
Yeah.
cost of silicon. And if I have 1,000 of them, maybe I have, giveaways that I can have that
Yeah.
increases the engagement on my, and like, it doesn't matter if the chip works. It's about the asset is the video content I created. I just need to
Yeah.
do a chip to have credibility in the video creation, right?
Oh, that's really cool.
And
Yeah.
I like, this is a person that otherwise, wouldn't do silicon. And I think that's kind of what the industry kind of doesn't or forgets, is that, like, if you look at what's happened in the PCB world, there are all these people doing random stuff that you're like,
Yeah.
that doesn't make any sense. Like PCB artwork, and, there are people building like PCBs that are motors, right? Like, you put the two PCBs together and the tracers couple and it turns and stuff like that. You're like,
Yeah.
that's a really bad way to make a motor. But like, if you want to do it, you can, right? Like, it's cheap enough that
Yeah.
they. And so, like, my goal with like Wafer Space as well is that I don't take any, I don't dictate who can access this. If you submit GDS that is manufacturable, I will manufacture it, right? Like, I don't really care whether you hand drew it, whether you used open source tools or whether you use proprietary tools, or like, that's not the service I'm offering. I'm offering, give me the DRC clean GDS and I will put it together and get it manufactured and send you back die. I don't care whether your
Yeah.
die is, like earrings, or whether it's a real chip for a startup. I'm just doing that manufacturing. I think that's what the PCB people are these days as well, right? Like,
Yeah.
if you
Yeah.
send them stuff that they can manufacture, they'll manufacture it to you and send it back. And so,
Yeah.
obviously, the open source tools very much help lower the barrier. If we had a wafer space service, but the proprietary tools were the only option, it would dramatically, the YouTuber isn't going to buy a Cadence, seat to do their silicon, because that immediately, all of a sudden, the, economics don't work out, right?
Yeah.
And,
Yeah.
Cadence probably doesn't want a person like them because they would drain from a, support aspect, right? Like,
For sure. Yeah.
but
Yeah.
like the open source tools, they can do that, right? Like, they can do all this stuff by themselves. And again, like, it's a risk versus reward for them. It's the first time they've ever done silicon. Is the thing going to work? I'm a bit skeptical, but again, it doesn't necessarily matter, because like, it's a means to an end, right? Like,
Yeah.
and like, that comes into education as well. One of the things I say is that, like, today, many students' first tape out is like on a 12 nanometer process technology. And like, that is crazy to me. Like, 12 nanometers is
Yeah.
like a
Probably too advanced
extremely
for to
advanced
start
process
out.
technology. They
Yeah.
get one shot because it's so expensive. They can only do it at their PhD because it's so expensive. All these type of things, right?
Yeah.
You
Yeah.
don't want to be learning, to accidentally forget to connect your GPIO enable pin on that process technology, right? You want to do it back on, 180 nanometers where it's only, $10,000 if you screw up, right?
Yeah.
And so
Well,
that's kind of
just to
another.
yeah, just increasing the access here is a really interesting thing to think about. Like, and if you think of some of the big picture outcomes here that happen, especially, I know that your tiny tape out and Matt Venn, even for like, will reduce the price down to like $200 or something even smaller for you just to run something interesting. But one of the concepts I see talked about, there's the over in the software world, there's a lot of discussion about AI and whether AI will destroy jobs. I stumbled across this a few weeks ago. Jevons paradox, right? So what's the Jevons paradox here? And he was a British economist that talked about steam production, and he noticed like when it got cheaper and even more efficient, people just consumed even more, and they did even more interesting things with it. So it was a little bit counterintuitive, whereas they thought it would just replace horses, and then the economy would get smaller. As the tool gets cheaper and as the access gets better, people just consume even more and more. So I wonder where that could possibly take the industry, just like you saw with like PCBs or even 3D printing, that they were there but they were kind of inaccessible to everybody until somebody came along, tweaked the business model, and then also tweaked the access to the intellectual property. And then suddenly there was this boom of people doing very unexpected things. I don't know. Do you have any thoughts on where that goes? Yeah.
So I have a whole talk about this concept. It's frequently called a learning curve or
Yeah.
Wright's law. Wright was a Navy researcher, I believe, who discovered that some things, basically, the more you use it, the cheaper it gets.
Yep.
Some
Yeah.
examples of this that are really important, I think, are things like silicon solar panels. That's right. Like
Okay.
solar
Yeah.
panels, if you look, have had an exponential drop in their cost over the lifetime. Lithium batteries and batteries have also had the same type of thing. And I think something that's kind of a parallel is what SpaceX has kind of done with rocket launching, right? Like the fact that rockets and like the cost to get stuff into space has become so much cheaper. The YouTuber that I know is actually looking at, buying space on a launch because, again, the cost versus the ad revenue now becomes viable. I think there's a YouTuber called Mark Rober who's like an ex-NASA
Yeah.
engineer. He
Yeah.
bought some space on one of the ride shares and put, I think, a cell phone into space so you could have space selfies or something along those lines. I can't
Yeah.
remember the exact details. But like, this is the thing, is that reducing the cost helps open up the market to a lot of different things. And
Yeah.
like, what might be stupid to you uh, might
Mhm.
be the next big thing, right? Like, and like the thing, it's kind of like if you in the BC world, there's that like idea that you know you need to have 100 startups to have one unicorn type thing. Thing is that like if it was obvious like what the thing that's going to be big was, people would already be doing it. Like the thing
That's a good point.
is going to be game changing in the space is the thing that everybody thinks is stupid, but like one person doesn't. And, a majority of the people who don't think it's stupid, their idea actually is stupid. Like 99 of them turn out to fail,
Y-
right?
Yeah.
But that one person who does, makes the next big thing. And
Builds a whole
so,
new
like,
industry. Yeah.
you don't want to, you want to remove those barriers. You want to give them as much ability to do anything as possible because, they're going to look stupid to you when they come along and say, I want to do this with your stuff. And you're like, well, if it's
Yeah.
no effort for me, I'm going to let you do it, right? Like, if
Yep.
I
Just
make money doing it, right? Like, okay, I'm happy to sell you the shovels.
yeah.
And, that's, I think, an important aspect that we
Yeah.
can
That's
enable in this
really
industry.
inspiring. Yeah. Yeah, just from everything, it sounds like it facilitates everything from education, especially a deeper education at an earlier point in your career, like you were saying, but also just to let more entrepreneurs or more artists take shots on goal and, see what comes out the other end, which is really exciting. Yeah.
Yeah.
Um,
And I think one important thing to think about is also the cost versus benefit ratio here is that like at the moment, one of the big problems in silicon industry is the cost of verification of the chips, right? Like, and some of this comes from the fact that like, if I'm spending $1 billion developing a chip, I want to be damn
mhm.
sure that thing works, right?
Yeah.
If I'm
Yeah.
spending $200 to develop a chip, like I'm going through tiny tape out, if it doesn't work, and I had some fun, who cares, right? So
Fair enough. Yeah.
if it's only $200, I don't necessarily need to do the same level of verification that a $1 billion project does, right?
Yeah. Yeah.
And I think that's a really important thing to think about is that like by making it really cheap, you can be a lot more experimental and the
Hmm.
cost isn't so bad when things fail, right? You can fail
Yeah.
a lot more than and still, succeed. An example
Yeah.
in the kind of
You're
startup
right.
world I kind of talk about
Yep.
is that like every software startup is, a person with a laptop and $50 of cloud credits, right? Like
Yeah.
that's the startup
Exactly.
in, the same stage of having market success. A hardware
Hmm.
startup is probably, 30 to 100 people having already raised 50 to $100 million today. Right? Like,
Yeah. Yep.
um, they've got the same amount of product fit and, the same amount of released products and all these type of things. Right? Whereas, if we can make it so that the startup is, somebody who had a couple of hours on the weekend and did a tiny tape out to prove whether the idea was, viable, like that's going to be so many more hardware startups that can exist, right? And like another thing to think about is, okay, maybe tiny tape out is a lot worse in many ways. Let's say it reduces the likelihood of your thing being successful by 10x. Just by the fact that increases the number of attempts you can do by 1,000x means that overall you're still going to be more successful, right? Like, and so like talking to the verification people, they're always like, but what about this verification or this verification or this verification? We're like, well, if we had infinite time and money, then sure, we'll do that. But like,
Yeah.
does it matter? And the most interesting example coming out of PCBs is that somebody tweeted recently that like they've stopped doing like a lot of review on PCBs
Hmm.
because the amount of time they spend reviewing isn't worth it anymore. Because if it comes back and it doesn't
Yeah.
work, they'll just do another spin and it'll be back again, so quickly. They're better off,
Yeah.
working on other things than, going through and double checking everything, right?
For the
And that's
triple
because the
check. Yeah.
cost is so
Yeah.
low and the iteration time is so fast. If we could get silicon to that, who knows what people would do with silicon and what they could get done. Like another example I give is that there's this guy out there who's created a like 2 3 years ago. He'd never done any hardware design at all. He has now
Yeah.
built a fully like a RISC-V SoC with memory controller and all these type of things that boots Linux.
Wow.
And he taped this out on Sky 130 through tiny tape out. And like
Yeah.
if you talk to industry, you'd say like 130, that's a terrible process technology to do a Linux capable CPU. And there's no way
Yeah.
you'll fit a Linux capable CPU in something as small as tiny tape out. Like there's just no way there's enough space there. But
Yeah.
he didn't really know that he wasn't supposed to be able to do
He
this
didn't
and
know
did
better.
this.
Yeah.
And, he's
Yeah.
obviously a very smart person. And obviously, maybe it's not as good as a Linux a SoC done by ARM or Qualcomm that had like 1,000 engineers working on it. But
Yeah.
it's probably, proportionally, if you look at the amount of effort, because he didn't do this full time. He did this
Yeah.
as a hobby, part time, after work in 2 years, right?
Yeah.
And the thing that I really love about this is that it boots upstream Linux with no need for any board support package or any of these type of
Wow.
things, right? Because he
Wow.
was an
Okay.
embedded software engineer and was like, screw this. I hate board support packages. They make my life, my day job hell. There's no way I'm building anything that doesn't work just on upstream Linux. And so like he built it, and like you can download a Linux kernel from kernel.org and set the right settings and compile it and install it, and it
And
boots.
he's off.
Like,
Wow, that's fantastic. And you know that and the concept you bring up is one we talk. I end up talking to startups a lot about too, which is you know they're probably there are different types of entrepreneurs, but sometimes the most interesting one is that they're too new to a space to know what's been tried or what has become essentially given and specific lore about everything. So you don't hear how everybody just says, oh, you can never build a chip that you can just put a Linux kernel on and start rolling with. You absolutely need the board support packages, and so it makes you just uninformed enough to be crazy enough to go ahead and give the crazy idea a shot. And this certainly, like you said, because you're lowering the actual capital cost of that, you're certainly like putting more of those folks out there or releasing them to the wild. So that's huge. So Tim, you guys, you're on the verge of getting back your first run now, right? So you're coming full cycle, and what does that look like? Backers get their chip sort of mid March. They get 1,000 bare dies, maybe packaged. I know you're doing PCB packaging around it, I think, right? What happens next for them, and what happens next for you?
uh, so at the end of March, we get the wafers out from Global Foundries, and then, I have to get them diced and sorted.
Yep.
As part of that, I have a contractor working basically on a die sorting robot, because the industry
Cool.
isn't set up for sorting something into 40 different bins, right? Like I have 40 different
Yeah.
projects on my design. Most, groups have 10 bins at once, right?
Okay.
And so, if you have 40 projects that each are getting 1,000 parts, that's 40,000 things that you have to sort. You don't want to do that by hand, right? Like,
Yeah. Yeah.
and so we had to build some custom hardware to do that. Uh,
Okay.
and again, I think this is probably, hubris of a software engineer. We'll see how it goes. In many ways, it's just a reverse pick and place machine. Instead of, taking the thing and putting them in the center on the board, they're taking the board and putting it in the rear pulls. I'm surprisingly confident that bare die as well is mostly not useful to people. So for these early runs, I'm working with another group to do chip on board packaging of the die, basically
Chip on
mounting
board.
the chip
Yeah.
directly on a PCB.
Yeah.
Because talking to the packaging houses, it just like the packaging, if I go a traditional packaging route, is going to cost more than the silicon itself. And I don't know how that works out economically, given, a foundry is $1 billion investment and a packaging house is, a 10 to $100 million investment. You just think from a cost of money, packaging should be, final cost a much smaller percentage. But so far, if I go through traditional packaging, uh, like story, it's going to add like on my $7 silicon, get it packaged. And so instead, I talk to the PCB people, and they're like, "Yeah, we could do wire bonding and stuff like this of the chip, and that is much
Really?
more reasonable." An
Is that
interesting thing is that like these PCB people are already doing PCBA as part of a value add service. If you make the PCB for them, doing the assembly for them, increases the value you provide to them, and also increases your potential margin, right? They're like, we we already offer wire bonding to, you know, customers that we have close relationships to. Because at the moment, many wire bonders basically, the way it works is you get a piece of paper with a drawing and a bunch of human writing on it. Even if, they've done big simulations of how it's going to perform and stuff, like the actual final thing when they're like setting up the wire bonding machine is
yeah.
frequently just a bunch of printouts that like have manually written instructions on. And so they're interested in this whole idea of like, well, if we can come up with a standard that allows people to specify wire bonding in the same way, Gerbers specify PCBs, and they can automate that so that as part of PCBA, you upload your, KiCad file, which has
Yeah.
bonding in it. They can quote
Yeah.
on that in a usable way that and do that in an automated fashion. But there's always going to be this chicken and egg problem. The only people who want wire bonding are people who want to do 1,000,000 units. And if you want to do 1,000,000 units, the cost of having a, customer representative deal with the languages issues of translating the bonding process is like worth it.
Yeah.
If you're only doing 1,000, like it doesn't make much sense for that overhead of humans involved. And so how can you automate
Yeah.
that away? I
That sounds
also
like
think like wire
another
bonding is
like
like you can get these things called known good die, which is basically parts that aren't packaged from vendors. And so I see a future where, as part of PCBA, maybe you get the custom silicon from Wafer Space, you get like a spy flash known good die from some vendor, you get some SRAM from a also a known good die, and you wire bond it all together in a little PCB, and this kind
cool.
of gives you some of
Yeah.
the advantages that things like chiplets are giving without
I was
like the
gonna say
massive
it sounds like,
cost,
yeah,
right?
chiplets, but at a more macro scale. That's really cool. Oh, it sounds like
And like
you're on your way to
even if you don't
transform
have
like
the custom silicon, like I think
yeah.
that as itself, like if the industry has access to that, there'll be a lot more, very small design stuff. And frequently size is a big factor in whether something is viable as well. If you think about wearables and all these type of things, or like every inch you're using on your parts is,
Mhm.
space you can't pack with battery, right? Like,
Mhm. Yeah.
and
That's a
so
great
like
point.
I think there's a lot of interesting things there. Sadly, we're not at that stage yet. There's still a lot of
Yeah.
work to be done to figure out how to work with these groups. But ultimately, I'm hoping have to get like I'm able to get out of the packaging space, and I end up just shipping people's bare die to these PCBA houses directly, and they do all the assembly, and then anybody can get any form factor, right? Like if they want it in a dick chip, you just design a little PCB that is like exactly like a dick chip, right?
Yeah.
It
Yeah.
opens up people to do like little castellated packages like they do with the ESP32s and that type of thing.
Yeah.
You know, all of these suddenly become options that people can do with their custom silicon. And like GF being an older process technology, like 180 is, late 1990s. And, it's a particular variant that has been cost optimized. So it's even less potentially functional than a normal 180. But it's cheap. Once you start going like, okay, I've got my custom ASIC and I'm pairing it with, some spy flash that's done on a modern process technology and an SRAM that's on a modern process technology, all of a sudden it starts to look a lot more competitive because like the big thing with the GF180 is that you don't get a lot of transistors in SRAM and flash per millimeter of silicon, right? Because it's still in the older technology where if you go to like 90 nanometers, the cost per transistor goes down, but the absolute cost goes up. To do a tape out at 90 nanometers, you need a lot more people to get the cost to the same uh, you know, place. And
Okay.
so I see like these future technologies as options, but only when, I'm selling out a, 40 projects a month because I know some of those people are going, okay, I want to go to a more advanced node and I'm willing to pay that higher cost because I already have a product I'm shipping, 1,000 of or 10,000 of, and it makes sense for me to invest that increased amount of money in the higher process node. Without that kind of
Okay.
ecosystem, I don't think it makes sense to try and do 45 nanometers because for 45 nanometers, I'm going to have to divide that by 200 or 300 people per run,
Yeah.
right, to get the cost
I
to
see.
be a
Okay.
reasonable, right? And so
Yeah.
I need at this kind of feeder. And that's kind of also where tiny tape out fits with wafer space is like tiny tape out in many ways is a feeder for wafer space because tiny tape out is in the process of adding support for GF180. So you'll be able to take first prototype for $200 on tiny tape out. You get one back and you're like, oh, you get a couple of chips back and you're like, they're now willing to put the more like $10,000 towards doing and getting, 1,000 chips back. And, maybe the first 100 would go to your prototype that doesn't work. Then the next 100 goes to the prototype that, actually works. And then you've got like 500-ish chips left to go to your first round of customers, right? And actually
Yeah.
show that this is a valuable product that people are willing to pay for rather than, and like that's all with the cost of the person's time and 10K worth of investment as opposed to today where that's millions of dollars worth of investment.
So that brings a good point. So your next run is in April, but then it sounds like you're going to take this like maybe down to 90 nanometer and 45 nanometer after that. What do the next few years look like for you? Do you have a sense of the timeline it takes to get there?
I don't have a sense. My goal at the moment is just to build the number of people on 180 nanometer GF180 MCU. So
Yeah.
that, one of the things I talk to a lot of people in silicon industry is that like, if you miss an MPW run at the moment, your
Yeah.
product is probably going to be a year delay, right?
Wow. Really?
Because like
Okay.
the MPW runs, especially on these advanced nodes, maybe twice a year. And there's frequent delays and all these other things that can make it even worse than that.
Yeah.
But if you miss it for whatever reason, it adds a lot of time to your, your turnaround, especially if you're not one of these big customers. Like I'm sure Google probably gets custom MPWs and all stuff like that from, the big guys because they see them as a strategic customer. But if you're like some
Yeah.
nobody like I am now, I guess, is that like they're not going to hold the MPW up for you and wait for you to submit your design.
Yeah.
Whereas if you had an MPW that happened every month, it would be a pretty big change in like, okay, if I miss this month, it's only a month delay. And, the way I think we get there is, well, okay, if you need 10,000 chips, that's really buying, like, that's still not enough that it makes sense to buy your own mask set, right? Like, you need to be in the like hundreds of thousands to maybe millions to like, as I said, like I get 40,000 chips back as part of my very short run. And so like at 10K, you buy 10 slots from me, right? And so if I get repeat customers who are just like, they didn't do any work, they just took their design they had previously and submitted it, or maybe they tweaked it to get it like slightly better.
Yeah.
That's how they get their chips, right? Like they order and they have to do a bit of planning because, it takes 6 months to get their chips back or maybe a little bit less than 6 months. But like they can do that repeat order to keep their chips in stock, even though they're only doing things. That means that they're going to be more people buying this, which means I can run more frequently. The other thing on the education side is this is a little bit of a fantasy, but 50% of high schools were to send one design a year.
Yeah.
So this isn't like a course. This is an after
Hmm.
school club at these high schools, like doing something and doing a design. I would effectively need to run an MPW once a day for the entire year. And
Wow.
at that point,
There's your scale.
I
Yeah.
worked out that I would be roughly 30% of the global mask manufacturing capacity would be dedicated just to me. Because like the reason this is like most people buy masks fairly like once and then produce millions of it, right? But I buy
Yeah.
another set of masks every time I do a run.
Yeah.
Which means you can change your design each time as well, right? Like that's a interesting thing that I think, people like Tesla and SpaceX have been, exploring is that like every version is another version, right? Like they don't stop moving forward. They don't go, okay, this is the same chip it was,
Yeah.
20 years ago, right? Like
Yep.
they every version is slightly better. And like that was something at Google with software, right? Like, okay, the compiler got 1% better every month. So that's 12% over month. And like it adds up over time, right?
The compound growth on it just goes. Yeah. Yeah.
And so like, but like at that point, when you're like 30% of the mask manufacturing capacity in the world, right? Like I'm sure the mask people are going to be like, okay, we need a better style of mask for you because you use your masks once, but the industry is set up for like these masks need to last 30 years, right? Like,
Yeah.
um,
Yeah.
they need to be used forever, right? And so like I've actually talked to a bunch of people in the mask manufacturing industry, and they're like, yeah, if you guarantee that you know you're only going to use these masks once, we would probably do things a bit differently than you know we do currently, and we could probably reduce the cost. And like coming from you know my side is like masks are probably between 60 and 80% of the final cost to the end user.
Wow.
So like
Okay.
if I could make
Huh.
that even 50% less, the silicon gets even cheaper, right? Like
Yeah.
the cost goes from $7 to you know $4 per chip. Um, and my like high level goal is to get us to a point where you can get 1,000 chips for $1, right? Because I think at
Wow. Okay.
a $10 product is viable, right? Like, you know, a $10 product with a $3 bomb, and $1 chip means a third is going to that chip. Then you've got probably like $1 covering the PCB and the jelly bean, and $1 covering, you know, your margin or other things. So, and like at $10 each, it's much easier to sell 1,000 $10 things than it is to sell 1,000 $100 things, right? And so I think that opens up that space. Plus, you know, again, I think it's just cool that you can buy this stuff for that price as well, right? Like you can
Yeah,
have
for
a piece of
sure.
silicon. Maybe the piece of silicon just outputs your name and you put it on your business card. Maybe that's cheap now that can be your business card, right? Like, or other crazy things like that. And to that accord is like run one, my cheapest option was like the $7 a chip thing. Um, for a bunch of different reasons, we've ended up with these things called half slots, which is about the area, which means on run two, for $4,000, you can get 1,000 parts that are about half the size of the uh, normal slot size. So for now, you can get silicon. You get 1,000, again, 1,000 units, but basically just by dividing the area by half, right? Like again, none of this that I'm doing is rocket science. Like I have a spreadsheet that calculates how much Global Foundries charges me and how many, you know, customers I expect to get, and you know, how much then I have to charge for, you know, the things so I don't lose money. But I'm
Yeah.
also not trying to like one of the things that I learned from Osh Park is like you might derogatory from the startup world call it a lifestyle business. Like Osh Park was extremely successful, but it was also like, okay, we're not going to be the next $1 billion unicorn. I'm not trying to be a $1 billion unicorn with Wafer Space, right? Like if Wafer Space stops growing at like you know, $10 million a year and has
Yeah.
3 to 4 employees, like I'm
Yeah.
happy with that, giving
Yeah, of
people
course.
access to that
Yeah.
silicon, right? Like,
Yep.
which is also why I don't need to take investors, right? Like I did pretty well out of being at Google for 16 years. I don't have kids or partner or any other, you know, costs. And
Yeah.
so I'm able to basically spend my retirement, you know, savings on trying this and seeing
Yeah.
what's happened, which also means like it's dependent only on me. There's not another investor that goes, you know, I don't want my shares to be diluted. I'd rather
Sure.
this
Yeah.
company not exist, or, you know, things like this. Because, like, if you mentioned you're from experience with startup laws, like, so many startups have really good technical ideas that then fail because of, you know, other reasons, right? Like it's enough just to have a good technical. You also need to be able to convince investors. You need to be able to raise money before like you get to the point. And all these things are different skills that are hard in different ways, right? Like as a software, I like to think I could do all of them, but like having met, you know, people who are good at marketing and these type of things, you know, having people who are able to do that it's easy to be 10 times better at that than I am, I think. And so like by making it cheaper, instead of spending all that money on the silicon, you spend it on buying time from the really good marketer or the time from the person who can help you make the business case make sense. Source is an enabler, but it's not a business model. Open source enables my Wafer Space customers to, submit designs cheaper, faster, easier, with less support from me. But like Wafer Space makes money because it charges more than it costs to do the aggregation, right? Like that's the business model. It's also like not, a unicorn business model, but it's a pretty good model that shouldn't lose money as long as I haven't screwed up my spreadsheets and, these type of things, right? Like
No,
it should be
I
a
would say
good
it sounds
business
like
from that side.
Yeah, it sounds like you have a great plan, and I know in the VC world it's a pejorative to call it a lifestyle business, but it sounds like it'll fit the market, and you'll have a huge amount of just an outsized amount of impact, right? It's fascinating to hear you talk about almost every segment of the silicon production supply chain, or you've got plans to transform it and already have kind of isolated where the bottlenecks are and where you have to innovate to make it better. If you if you had a big pile of money right now, I don't know what you would dump the pile of money on. It sounds like you have good control over it.
I have plenty of ideas of how you could accelerate a lot of this. So how you could, like, even at the prices I'm making things cheaper, it's still non-zero cost, right? Like compared to software where I can, get a piece of hardware I probably already have for my entertainment, my laptop, and just start coding with things like GitHub are totally free. I don't need to, pay anything. It's just my time. So like that's an area I think like if I had a big, say was Larry or Sergey, made by billions on Google, that type of thing. I think you could just run a thing where you fund, a silicon lottery, and you could easily it wouldn't even be that much money, right? Like you could have a run a month where you give, let's say 10K per person, and there are 40 people on a run. That's say $500,000 a run. If you were to say, well, I want to do 4 runs, that's $2 million. You could say, okay, I'm going to spend $2 million a year to run a silicon lottery. And the way I do it is like, I would have it be almost entirely automated. People submit their designs. Nobody tries to evaluate which are the good designs. You just get a lottery ticket, right? And if you get onto the lottery, you get onto a lottery, right? If you try and go to the idea, you're going to bring your preconceptions about what a good idea is into this. If we do things the same way the current industry does things, like trying to pick winners and that, you'll end up with the current same industry, right? And, the current industry has done a lot of stuff, right? Like, don't get me wrong. The fact that they've done Moore's Law for as long as I've been alive, like that, I don't know how they managed to do that. I don't know how you raise enough money to build a modern foundry. That just boggles my mind that you can make a viable business out of something where you have to raise $1 billion before you can even start thinking about doing anything, right? But
I don't think the private sector does that anymore. Yeah, that's done by governments now.
I mean, TSMC manages to keep deploying very expensive foundries, and continue to push it, like the engineering they're doing to with partners like ASML and Apple and these type of things to keep squeezing, juice out of what should be, I think, it doesn't make any sense that they're still able to do this given, and, they have lost in some ways on the economics, but, that may actually be good for business, right? Because they're able to, continue to charge the same margins on every new technology instead of getting squeezed by the cost going down and people demanding cheaper stuff. But
it is amazing to keep on squeezing keep on pushing closer and closer to the laws of physics, right? So
when I'm talking to non-technical people, I like to say that what we did was we hit, rocks with lightning and made them
Yes.
think, right? Like that
That's a great,
is as close as magic we actually have in real life. Like it,
yeah.
it makes no sense that you can make a billion of something, right? Every NVIDIA GPU, I forget what they're at these, but like has billions and billions of these that all work,
Yeah.
right? As well as other
Yep.
thing, right? Like that's amazing.
Yeah, every time. Gets it right every time.
I'm surprised how,
Yeah.
like,
Yeah.
coming from a software world, like one of the innovations of Google was this idea that, like, with data centers, instead of trying to build really reliable hardware, we will take this hardware that, is cheap because it's commodity hardware and make it the software engineer's problem to deal with the fact that it's going to fail all the time. And,
Yeah.
instead of like today, everybody's like, that's a normal thing to think about. Is like, okay, how do I make a system where, hardware fails all the time and still keeps running? Well, in some ways, it just, automatically behind your back does it for you. But before that, people are trying to build these things which have quadruple redundant power supplies with one power supply, but it adds a lot of complexity. Having 4 power supplies, all of a sudden, they can fight each other and stuff like this. So Google was just kind of like, well, our software engineers are smart. They can figure out how to deal with the fact that, servers will just go offline randomly in the middle of doing things, and, that type of stuff, which is like terrible from a software engineer. Like it brings so many problems, but like it made economic sense. And that's how, like, nobody thinks Google's down, right? Like if you can't access Google, your stuff is like, it's your internet provider or your computer that's broken, not Google. Right?
Yeah.
But like it's built out of the same unreliable hardware that you have at home. Think about how frequently your own computer misbehaves and all these type of things, right? Like, and they were just like, screw it. It's the software guy's problem in many ways, right? Like,
you guys were inexperienced enough to just take on the problem. And here we are. It worked out. If you were a talented 22-year-old double E graduate, came out of you and said, well, they want to build their career now in open source silicon, what do you tell them? Where do they go? And like, how do you point them towards the next big thing or to building their own thing? Yeah.
I think the big thing is you want to do as much as possible, as quickly as possible, even if you don't think it's going to necessarily be super relevant, right? Like,
okay.
Go and make it a mission to have something on every single tiny tape out that happens.
Okay.
Because just through going through the process, you're going to start, learning things, and you're going to start going, I wonder why this thing is like this thing. And, I think very few undergrads get to do tape outs. It's becoming a lot more prevalent thanks to things like tiny tape out, and there are universities that do offer it, but they tend to be fairly exclusive elite universities. And if you're a student at that, you've already got a job offer at somewhere that you're going to. I would say that like my advice is more targeted at people who are kind of entering this from a less privileged position, is make sure you can eat and these type of things, but there's a tiny tape out once every quarter. It's $200-ish, instead of eating a fancy meal, go and get something
at
on
$200.
And
yeah, that's right.
At the end of the year, you're going to have 4 tape outs. And I'm pretty sure with like 4 tape outs and 4 chips in hand, walking into a job interview, you're going to be ahead of everybody else just from that.
That's a great
point.
You
might also find like, hey, wait a sec, I'm still young and excited, and I have an idea that seems crazy, and maybe it is crazy and won't work, but you can go and try it. You can do some test tape outs with tiny tape out, and then see if you could sell 1,000 of them, right? Like if you could sell a product at $1,000, and there's 1,000 of them, that's not too bad. It's not, a huge amount of money, but it's
you get electrical engineering degree,
it, right?
Yeah, you get electrical engineering degree and you get a business degree there too. Sell them, and that's like better than an MBA and probably better than a master's in electrical engineering. So yeah, all for
Yeah.
$7,000. If you go the 1,000 route, right? You can start for 200 and work your way up. So
Yeah, but that's
you
the other
should.
thing is like once you've done 4 tape outs, you also know whether or not you like it,
Yeah, that's
hopefully.
true. Yeah,
Because like if you haven't done tape outs, you might be like
yeah,
at the end of this, you know, I really hate tape outs, right? Like
yeah.
I
I
should go and become a software engineer, or I should go and, work on the
yeah,
electricity grid and, these other things,
yeah,
most skills in engineering are like surprisingly transferable. The kind of like logical thinking and working through these processes
yeah,
is just a generally useful skill as
yeah.
well. Like I'm kind of an old fart these days. Like when I was growing up, there wasn't a thing called a YouTuber, right? Like,
Yes, that's
you
true.
know,
You're right. Yeah,
who knows what the job market's going to be 5 years from now, right? Like if you had 5 years ago told me that what AI could do now in coding, it could do,
hmm,
like I would have laughed at you and said, like there's no way it's going to get that good in that short a period of time. And,
yeah,
now it has.
yep,
But, I'm not necessarily scared of that. And I don't think software engineers should be scared of that because I feel like there's infinite work to do, right? Like I've never been
yeah.
anywhere where there's there's never enough resources to complete everything you want to do, right? You always have to prioritize. There's always like things that are getting forgotten. I think AI is just going to like accelerate the fact that, okay, well, you might get through your task list faster, but an infinite task list never gets shorter.
That's right. Yeah. Well, that's comes back to Jevons paradox again, which I think is why that came up on my radar because as something gets cheaper, people consume more of it.
It kind of defies logic, like it shouldn't work, but we have lots of evidence it does.
Yeah, that's
And
right.
like there are theories, like it's also very related to the network effect, right? Like, and the idea that, you know, it's just a numbers game, right? Like you need to have, as you said, shots on goal. And in many cases, I don't know if this is true, but like having a more competitive market that has slimmer margins reduces the likelihood of success, but
Yeah.
also increases the number of people attempting to like have that shot on goal. So even though every shot is, a tenth or 100th less likely to succeed, the fact that there's, 1,000x, 10,000x, 100,000x more attempts means that overall the system, has more successes. And I think that's really cool. Like, and that's kind of also why I'm doing this. Like, I don't want people to have to ask for permission here. I want them to do cool and me to learn about it and go,
Yeah.
that's really cool. If I help make it happen, that's even better. But like, I want to see more cool stuff, right? Like if I'd been, living at a different time, things like the learning disabilities I have may have been a thing that, I wouldn't have had as a good a life as I do today. And
Yeah.
so like, the modern world has given us miracles, and like a lot of the most recent modern world is built on the back of silicon, right? Like the
That's a
fact I'm
very
even talking to
software.
you right
Yeah.
now is built on silicon, right? Like
That's right. Yeah.
100 years ago,
Somebody.
I would have never been able to even contact you, right? Like even
That's
if
right.
I was like the US president, like the most powerful person in the world potentially at that time, I wouldn't be
Yeah.
able to do what we take for granted today, right?
The poorest person today lives a life that royalty 100 or 200 years ago couldn't even imagine, right? Yeah, it does give you a lot of perspective.
I think we've just barely scratched the surface of what the open source community can do. Like I look at it and to me, it looks like the open source software industry in the early 1990s. Linux was this weird thing that, hackers occasionally installed on their computer and it was like a pain. It wasn't, it like, I think that's where we are. Compilers like take System Verilog, which I think is kind of a parallel to C++. I think
Hmm.
in the industry, there's a lot of issues around like different tools interpreting system Verilog in different ways, which means you need to have stronger verification teams and stuff like this,
Yeah.
because you
Yeah.
might hit a bug that, and like in the software world, there's this kind of adage, it's never the compiler, right? It's always
Yeah.
your code that is broken. That only happens though because the compiler has so many users and so many
Yeah.
people working on it, right? Like when I
Makes
started,
sense.
it was the compiler some of the time, right? But
Yeah. Yeah.
because every bug that you're likely to hit has probably been hit by somebody else before you got to it and fixed,
Yeah.
right? Means you're
Yep.
not going to hit that bug. And it's just a number. Again, it's a numbers game, right? Like
Yeah.
there are so many people banging on it. And like from big multi-billion-dollar corporations like Google to individual developers are
Hmm.
all contributing to this, right? Like take Linux kernel. I forget what percentage is, but I think it's about 10 or 15% of people like commits to the Linux kernel come from individuals doing it as a hobby, right? Like, and
Wow.
this is
Huh.
something that is like, driving global commerce, right?
Yeah.
Like
I was gonna say the
cloud
entire
runs on
world runs
Linux,
on that. Yeah.
mobile phones run on Linux, like Android, Chromos, they're all built on top of Linux.
Yeah.
You know,
Yeah.
but like you wouldn't have known that Linux would be the one to win here either, right? Like
Yep.
there are
Yeah.
plenty of competing options. There are BSDs and Mosics and all these other things. There's the famous thing of Linus Torvalds getting into an argument with his operating systems design professor about how he was building an operating system the wrong way
Yeah.
and that type of thing. So like that's other things like we don't know what's going to be successful here. And so that's also like why I welcome the fact that there are multiple competitors to Wafer Space now as well that are focusing on
Yeah.
different areas. Out of Efabless came chipfoundry.io. They are doing Skywater. So if you want to continue to do Skywater, Chip Foundry is a great place to go. They're a
Okay.
little bit more expensive than Wafer Space is, but they're much more hands-on in helping you. And the technology has a lot more features that you're not going to find with Wafer
Hmm.
Space, right? Like,
Okay.
and so like if you need those features, that makes sense. And then in Europe, we have IHP. The foundry directly is offering this. And we didn't even talk about
Huh.
IHP, is that like
Yeah.
Google didn't make IHP happen. Google made
Okay.
GF180 and Sky 130 happen.
Okay.
I had a meeting with some people at IHP and told them how I did it. And then I think it was a year or maybe it was 2 years later, the PDK, I heard that they were releasing the PDK and saw it at the same time everybody else did, right? Like
Okay.
it wasn't a case of
They went ahead
Google,
and
they did it themselves, right? Like
okay. Wow.
and I think for them it makes a lot of sense as well because they're in a similar position to Skywater, a small foundry. They have a bunch of unique, interesting things like I can never remember exactly which, but I think it's silicon germanium, like high bandwidth bipolars that lets you do like 300 gigahertz type technologies.
Cool.
But like a lot of the problem is that people don't even know they exist. And like, if you had a choice, why would you use this small foundry over somebody like TSMC? The risk is so huge, right? Like, you go with TSMC, even though TSMC's products doesn't have these features because your investor's going to say like, okay, you need to use the industry standard. Industry standards TSMC.
So
right?
so if I understand, HP was also like Global Foundries looked over at Skywater and said, we're small and we're not as well known. We need to get the same amount of attention, and that was the motivating factor, you think, for them to open their PDK?
I don't know because I wasn't involved in it, but like this is my current theory is that like running a foundry is expensive and they need more customers. Is effectively the angle I saw, and like I think they're succeeding there because like there's a bunch of people who are now doing things like I think it was like a 300 gigahertz transpedance amplifier
Okay.
and they did it with IHP, but like they were a small startup that from a country that isn't the US. And so even getting the time of day of like the proprietary tool vendors and stuff like that is they couldn't do it, right? Like, and so they wouldn't exist if it wasn't for the fact that they didn't need to ask anybody to do, this project. They could do it because of the access, right? And I think
Okay. Huh.
there's underutilized groups in like Africa and Latin America and all these other
Hmm.
places which have never
Yeah.
even had access to silicon before, that places like Tiny Tape Out and Wafer Space provide this access, that they can do cool things. And because they come from, different mindsets and different cultures, they may approach things in different ways that give us, cool things we would never get otherwise, right? Like,
Yeah, for
um,
sure. Yeah.
having a different perspective on things means that like you're likely to have a different solution.
Yeah.
So,
That's great. Thank you so much for all you're doing to like inject as much creativity or enable as much creativity to kind of flow into semiconductor space. I'm sure we'll be looking back on this in 10 to 20 years and say this really was a inflection point. So thanks.
yep, I hope so.
Mhm. Well, Tim, it's been great to talk to you. Tell me if people want to hop right onto Wafer Space, it's wafer.space. And that's where the access to the next MPW that comes out will be. You can find it through that. Is that right?
Yep.
And is there anywhere else on the internet that people should be looking for you or following you?
So there's a very active Discord community that
Okay.
people can jump on and talk to other people doing silicon.
Everybody's going to Wafer Space after this, and to the GitHub repo there too. So